run through finding a resultant course or adding vectors. So this means if we have a course that we're actually steering 25 knots at 135 degrees H for heading, with a current 3 knots at 75 degrees H for heading. Now remember, these could be, for instance, this looks like, to me, look like it's a boat. If it was a plane, then we'd probably be using miles per hour. And instead of current, we'd have wind, but it's the same idea. The idea is we have some course we're going to steer, 25 knots at 135, so something like that. And then the current is going to happen to us, so a 75-degree heading, about 3 knots. And then what will happen is the resultant will end up being this, our purple vector. That's our resultant vector. So remember, this was the, in this case, current. We'll use C for current. And course. Oh, wow, that's horrible. So here we're going to have to use something else. Let's say S for steered or something like that. But that is what we're trying to find, is the resultant, which comes from adding the vectors. So here's the process. What we're going to do is first find the components of each vector. To do that, before we get too carried away, is we're going to take our heading and convert it into direction. Remember, degrees heading plus degrees direction equals 450 degrees. So we know that this 135 heading is really 450 minus 135, or 315. The reason that we want to use the 315 preferentially is because it makes the calculations a lot easier. Now the 75 works the same way. 450 minus 75 is 375. Now if that bugs you, you really don't want to use 375. If you subtract 360, that's really the same as saying 15 degrees direction. So when you're finding the components, so to actually find the components, what we need to do is get rid of that, make ourselves some space. For the course, it's going to be the magnitude, which is 25, times the, well, the x is always going to be the cosine, just like the unit circle, of the direction, so the 315, comma, 25 times the sine of 315. Current, same idea, C-U-R-R, except different magnitude, cosine, different direction, different magnitude, sine, different direction. These are the components. Because we're trying to find the resultant, that is, we're adding, finding the result, the effect, if you will, of the current on the boat's course, then we will end up adding these. Now, here's what I would strongly recommend. These are going to be two numbers, x coordinate, x component, y component. Type these into your calculator all at once. So 25 cosine 315, add them, so then plus 3 cosine 15. This will reduce any intermediate rounding. In fact, we won't be doing any. It'll be 20.575 for that coordinate. And then if you do the same thing again, except we're doing sine, give me a sec here as I busily calculate, but we basically repeat the process, except we're going to take the sine then of these, and that will give us negative 16.901. These are the components of your answer. So this means we've got some vector that's going this way, direction 0, 20.575. We've got another vector, that'd be direction 270, right, at negative 16.901. We don't care too much about those in particular, but what we do care about, well, we do care, let's be honest, you always care, but we do more so care about what the actual magnitude and direction of the resultant will be. So to find the magnitude, all we're going to do, because remember, all this really is, if you think about it carefully, this is the x component, which is 20.575. And then the y component, which is heading in the negative direction, taken together. So this is actually the negative 16.09. The negative serves us to put us in the correct quadrant, which is going to be important here in just a sec. But to find the magnitude, it's a simple matter of finding the hypotenuse. So the magnitude would equal the square root of the 20.575 squared plus, get that over there, 16.901 squared. Please bear in mind treating these as positive or both is going to make life a lot easier, less room for error depending on what sort of calculator you're using. 20.575 squared plus 16.901 squared is 26.626, and that would be knots, just to make sure. So if we started with knots, we're going to end with knots. That would be the magnitude of the resultant. To find the direction, we need to be a little bit more careful. So I'm going to have to create some space here. Forgive me. What we're going to do is, now that we have these components and we got everything drawn, what we're going to do is take the tangent inverse of these two. Because remember, what we're trying to figure out is this angle here. So let's call that angle theta, and to find that angle, we're going to take the tangent inverse, because this is the opposite and this is the adjacent. The tangent inverse, is it always going to be tangent inverse? Yes, as long as you construct this, so, well, as long as you construct it x and then y. Tangent inverse of, in this case, 16.901 over 20.575. So this ends up being a number, and it ends up being an angle measure, as a matter of fact, but it is not, I repeat, not going to be the heading. So 16.901 divided by 20.575 is 39.4 or 39 degrees. That is the angle inside of this triangle. So if you're looking carefully at this, we're looking at the angle, that is this angle right here is 39 degrees, but just that angle there from here to here. In order to find, in this case, we're given H for heading. We need to remember that heading is 0 degrees is up here, right? And then this is 90 degrees, which means if we're looking at this, this heading, this vector right down here, is going to be more than 90. How much more? 39 degrees more. So that would mean that the heading would be 90 plus 39, or 129 degrees heading. This means our final answer would be, for the effect of the current, 26.62 knots at 129 degrees heading. This means if the ship steered a course of 25 knots pointed this way, then the current will cause it to actually, so another way to look at this is you could look at this as, this could be your actual, come back to me, there you go. The actual course is another way to look at that.